Good evening, Charantej. Good evening, Prashta.
Good evening, sir. Good evening, Chris.
Yeah, good evening, everyone. Am I audible? Yes, am I audible?
Yes, sir.
Okay, so we were doing about force and pressure. Today we will see calculation of pressure. How to calculate the pressure. We had seen the formula of pressure in the last class. So we had defined also pressure. So all of you turn on your cameras.
Good evening, sir.
Yeah, good evening, Pranav. Gagan, Prashta, turn on your cameras. And so who will define pressure?
Sir, it is
Yes,
thrust by unit area, sir.
it is thrust by unit area. Very good. So,
Means the force applied into a particular amount of area.
okay, the force applied in a particular amount of area, we call
Sir,
that as the
the
yes.
effect of force depends on the area of pressure.
Okay, yes. It is a very important thing you must remember that the effect of force depends on the area of contact. The same force can bring about different effects depending on how much area is it acted upon. If the force is acted upon on a smaller area, so how much of the effect will it generate? Okay, what
Sir, back
effect will
strips,
it
sir.
generate? If the same force is acted upon, if the same force is acted upon on a larger area, its effect will be lesser. Like we studied,
Sir, back strips.
yeah, we studied about in the last class. I showed you a person lying on a bed of nails. So if you have a complete bed of made of nails, so the person can lie down easily. He will not face any problems. The reason being that if there are no with those nails, the area of contact with his body increases, whereas the force with which he is there, the force with which he is lying over there, the force remains the same, but the area of contact is more. So by the due to increase of area, the effect of force has decreased. In the similar way, I told you about, suppose uh, if you
Sir,
take
two screws, sir.
what?
Sir, two screws. One is sharper one and
Yeah,
another one.
yeah, two screws. If you take,
Sir,
uh, yes,
can you just brief on what you told before? Because this is my first class.
okay, Srishta, very good. So thank you for reminding me. This is your first class. So let us see. And all of you keep your camera on. I must see
Good
everyone's
evening,
camera.
sir.
Good evening. See, if you have any work, suppose sometime you have some work, you want to drink water or anything. So you can drink water in your class only. Okay. Keeping your camera on, there is no such issue. You can continue to drinking and some activities you can do like. Okay. But it's not that you are eating and you are studying, that two activities are not possible. So let's see. In this chapter of force and pressure, in the beginning, we had studied what is a force, right? So we had seen that a force is a push or pull. We had defined a force as a push or pull. Whenever we observe a push or a pull, so we call this as a force. If you are experiencing, someone is pushing you, someone is pulling you, you are pulling something, you are pushing something. So you are applying a force on that object. Okay. Remember, force has two specifications. The amount of force is called as magnitude. So you know amount of force, and there is another quantity which we should know about the force, that is the direction of force. The two things for the force, they are very important. In which direction the force is acting and what is the amount of force that act. For example, suppose if you have two forces which act, let's say you have two forces of 20 Newton each. Okay, there are 20 Newton, two forces. So if I tell you what will be the total force of them, so can anyone answer me?
Sir, 0.
0 or 40?
Sir,
Sir,
in the same direction or opposite direction?
Yes. So we must know the direction. We cannot decide without the direction. If we know the direction of force, then only we can decide that what will be the net amount of force acting on them. For example, here we have these forces. So let us say these forces, they can act something like this. The two forces, they may act in the same direction. They may act in the same direction on the same body. So this, if they are acting on the same body in the same direction, something like this. So the forces will add up and they will create a net force. Here you will have a net force of 40 Newton. If this is your 20 Newton, this is your 20 Newton, you have a net force of 40 Newton. So net force will be equal to 40 Newton, right? Here if you
Sir,
have,
is Newton, is
yes,
Newton like the unit of force?
yes, Newton is the unit of force.
Okay.
Newton is the SI unit of force. This is the unit in which we measure the force. Now, if the same forces, they are acting in opposite direction, like
Sir,
hmm,
sir, like Newton is like the weight also, right, sir? Weight of the object.
okay. See, weight and force, they are the same thing. Weight is the
Yes.
gravity. So weight is the type of force that is acted upon by the gravity. So again, here also you observe that 20 Newton force act in two opposite directions, right? So what will be the net force here?
0, sir.
0. Here I will get the net force to be 0. Okay, if the two forces, they are acting in some other directions, like we observe the two cases, the two forces, they may act in different directions, something like this. Suppose one force is acting here, another force is acting here. So in this way, here it's not possible for us to add the two forces. But yes, definitely they will be added. So what we want to say that the amount of force, that is there, the amount of force is dependent on the net force of an object. It depends on magnitude of the force and the direction of force. So both the things, they are important here. In which direction the forces are acting and how much is the amount of. Okay. Now, if there are a number of forces acting on an object and their sum added up becomes 0, like here you have these two forces and let's say you have some more. So you have added them and your net force becomes 0. So such a situation where you have a number of forces added together and their net force is 0. So in such a case, we say that our forces are balanced. We will say that the forces are balanced forces. So, Gagan Samudra, can you explain what are balanced forces?
Sir, Gagana, sir.
Yeah, Gagana. What are balanced forces?
Sir, when two forces are acting in the opposite direction and both the forces are balanced or having the same quantity, they are called balanced forces.
See, if you have a number of forces, not only two forces. If you
sir,
have a
I
number, yes, Pranav.
sir, if a particular number of forces are acting on an object which are equal in quantity, or we can measure in newtons. Those are called balanced forces, sir.
If there are a number of forces acting on an object and their net force is zero. Net force means if you add up all them and you are getting zero. If the net sum of all the forces acting on an object is zero, then we say that the forces are balanced. For example, we studied about, yes, last year.
Sir, yes, sir. Sir, like balance the forces means like it can balance the object in it can balance the object and the force and direction of the object, right, sir?
Yeah, definitely the total forces is zero. Okay. Now,
Yes, sir.
okay. What is there anything that the balanced forces can do?
It can
Sir, it can
change the direction.
sir, it
Balance,
can change the shape, sir. Shape.
yes.
Sir,
Balanced
it can
forces,
Direction it can change.
no, balanced forces cannot change the direction.
Sir,
Sir,
it
like
will not move anywhere, right?
it
Where
can
there
change
is
the shape, sir.
the
Yes.
weight of the object.
It
No.
can reach the shape, sir.
Yes, balanced forces can change the shape. They cannot make an object move. They cannot stop an object. Okay. They can
It is
just
fixed, sir.
yeah, it is fixed. So they can change the shape. Can you give any examples at your home of the balanced forces?
Say paper in the
Cabinet.
circle rocket.
Okay, have you seen your mother making chapatis?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Does she apply some force from the top?
Yes, sir.
Okay.
Yes, sir.
And there is some force from the bottom also. That is applied by the thing that is kept below
Yes,
that.
sir.
Okay.
The down, the force will be going down to up, which is down.
Yes.
From the down, it
So,
goes up.
okay. So can I say that the forces are being utilized to change the shape?
Yes, sir.
Yes. Over there, the forces are balanced and they are utilized to shape that chapati. So the balanced forces, they can change the shape of an object. For example, suppose you use that molding clay. Okay, you have used that molding clay. Using that molding clay, you can mold it into different shapes. Okay. So for that also, you need to apply balanced forces. The forces have to be, okay, can you just imagine, can you just keep your clay somewhere in air? Keep your clay somewhere hanging in air and
No,
you apply some force from here. Will you be able to change its shape?
no, sir.
No. You need to
No.
apply the forces, balanced forces, some force from here. If you are holding
The
it from
force
the
should be
downside,
down.
yeah. See, if from your fingers you are applying the force from the top, then from the bottom fingers also you are applying some forces for them to be balanced. Okay. So balanced forces are there which can change the shape of an object. Like I told you about the example of a sponge. If you have a sponge, so what can we do with the sponge?
We can
Yes.
we can
If
squeeze
you,
it.
yeah, if you squeeze it, so you are applying balanced forces and that is changing the shape of that object. Okay. So balanced forces can change the shape of an object. And what can unbalanced forces do?
Sir,
It can't
unbalanced force
balance.
means
It can
sir,
change the
when many,
direction.
Yes, unbalanced
Sir,
forces. Yes.
sir, when many objects act upon an object, but their sum is not zero, it is called unbalanced forces.
Okay. If a number of forces are acting on an object and their sum is not zero. So here, the sum of forces acting on an object the sum of forces acting on an object is not zero. So we say the forces are balanced. Forces are balanced. Forces are unbalanced. Not balanced, they are unbalanced. So here we observe that the forces, they are unbalanced. and hence they can do different things. So what are the effects that can be brought about by the unbalanced forces?
Sir, it
Krishna,
can move an object from one place to another place, sir.
okay, it can make it can make an object move.
Yes, sir.
It can make an object move, or it can make a stationary object move. It can make a stationary object move. Then
Hmm.
yes,
Sir,
what else?
it can make a object to move in a definite direction.
Okay, it can change its direction. It can change the direction of motion.
Sir,
Yes.
it can produce like I'm saying in a bit deep, sir.
No.
It can produce energy such as sound energy. It can produce, no, sir.
See, when you are talking of energy, energy can never be produced. Okay. We generally say energy is produced. Energy can never be produced. You can do work with your food. Okay, some work can be done. So let that be there only and not include here. Okay. So unbalanced forces, it can make a stationary object move. It can change the direction of motion. It can stop a moving object. It can stop a moving object, and anything else? It can change the speed of an object, right? It can change the speed of an object.
Sir, it can change the motion of an object.
Yeah, that we have included. It can change the motion. That means it can either speed up or it can speed down. It can it can
State,
change
sir.
the
It can change the state of the object.
okay, it can change the state of motion of an object. So these are the different things that the unbalanced forces can do. Then after this, we had done about the contact and non-contact forces. So what are contact and non-contact forces?
Sir, contact forces are physical forces which act on an object, and non-contact forces such as magnetic force and gravitational forces are which do not
Non-contact
share a
forces
physical
are allowed,
contact
sir.
but can
Sir,
provide the force.
non-contact forces are electrostatic force.
Okay, non-contact forces, they are electrostatic forces. Is
So
Shrestha here?
gravitational force.
Is Shrestha here? Shrestha?
Yes, sir.
Okay. So Shrestha, can you tell what are contact and non-contact forces?
So I haven't learned about them.
No, from the word, what do you think? What should be the contact forces?
Something that actually comes in contact
Yeah. So
physically.
that's yes. So the contact forces are the forces.
That come into physical contact.
Yeah. Are the contact forces are the forces which act only when two forces are in contact with each other. Just 1 second. Hello. Okay, just 1 minute. Just 1 minute. 1 second, right? It's an emergency. Just 1 second. Hold on. Okay, so contact forces are the forces that act when there is a physical contact between two objects. They cannot act without a physical contact. Okay. So the contact forces are the forces. Yes, and Lasya, any doubt?
Sir, like you're saying, like the contact forces which come in contact with together.
No, they do not come in contact with together. The contact forces are the forces which act only when they are in physical contact with the object.
Okay, sir.
Okay. So they cannot act otherwise. They act only when they are in a physical contact.
Sir, even sir, we have coming up subjective objective exam, right, sir? We have
Yeah.
even this also, sir, like contact and non-contact forces also.
Yes, everything from this chapter, force and pressure, everything is there. You have 10 questions, 20 minutes to answer.
Even pressure also, sir.
Yes?
Pressure also. You just started, sir.
Yeah, pressure also.
Okay, sir.
Pressure also is there.
Till
So,
today, till today, what we completed, those all are there, sir.
yes, whatever we have completed till today.
Okay, sir. Okay, sir.
But they
Okay,
may
so
even
everything.
ask what is the SI unit, sir?
SI unit. SI means International System of Units.
No,
So
sir. My doubt is in the exam they may ask even this. What is the SI unit of pressure?
yeah,
Force.
anything can be asked. Anything from the chapter. Whatever you have
Okay.
studied, anything can be asked.
Yes, sir. Thank
Okay,
you, sir.
sir.
Thanks a lot, sir.
See,
So
okay.
what is the SI unit of pressure?
SI unit of pressure is Pascal.
Okay, sir.
So see, the contact forces are the forces which act only when they are in a physical contact with the object.
Sir, does contact forces and non-contact forces come under unbalanced forces?
Uh, Even the contact forces can be balanced or unbalanced. Even the non-contact forces can be balanced or unbalanced. Okay. So balanced or unbalanced is a different phenomena. Contact and non-contact is a different phenomena.
Okay, sir.
Okay.
Sir,
Yes.
just now you said that contact forces can be balanced and unbalanced, no, sir.
Yes.
But
Yes.
then can you say some examples of non-contact unbalanced forces?
Yeah. Of course, there non-contact forces you can have unbalanced also. You can have balanced also. For example, something like this. Suppose you have two magnets.
Yes, sir.
Okay. So you have two magnets over here, and let's have like this. You have two magnets. If I show you the unbalanced state, so let's say you have one magnet, you have the north pole here and south pole here, and I place an iron object over here. So the iron object will feel an attraction towards this magnet.
Yes, sir. Yes, sir.
Okay, and hence it will get attracted towards the magnet.
Yes, sir.
So what type of force is this? Balanced or unbalanced?
Unbalanced, sir.
This is unbalanced force, right? So this is unbalanced force. Because of the unbalanced force, this magnet can bring this iron object in motion. Now,
Sir, what about balance and non-contact?
So
okay,
it can
okay. What about if I place another magnet here, which is same distance as here? Distance of both the magnets is same, and both the magnets they are strong to the same extent.
Sir, they both won't connect, sir.
So this iron is attracted towards this magnet also. This iron is attracted towards this magnet also.
Yes, sir. But
Okay, sir.
north and north pole won't connect, right, sir?
North and north pole repel each other. So
Yes, sir.
similar,
That's
similar. But here I am talking of the iron object. The iron object will be attracted by this magnet also. It will be attracted by this magnet also.
they
Sir,
both
this is
So
connect
a
each other.
yeah. So
Sir, this is an example of magnetic force. Can we have an example of non-contact in gravitational or electrostatic force of balance and
yeah,
unbalance?
yeah. Of course, you have non-contact force, gravitational forces. Over there also you can have balanced and unbalanced forces. Okay. With the case of gravitational forces, let us see some of the unbalanced forces. So if I tell you, why do the fruits fall down? Why do the fruits fall down?
Because
Gravitational
of the
force.
gravitational force.
Okay. So in that case, is the gravitational force balanced or unbalanced?
Unbalanced.
Sir, unbalanced.
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 Yeah, the gravitational forces are unbalanced, and that is why you have that object moving in the downward direction. Okay. In the gravitational cases, we can have balanced forces also. For example, suppose when you are swimming. Yeah. So it's summers, now you can swim. So you can swim mentally. Here I have made a swimming pool for you, and in this swimming pool, suppose you are here, you are swimming over here. Okay. So the gravity is pulling you downward. Here, the gravity is pulling you downward, but the upthrust of the water is pushing you upward. So the two forces are acting opposite to each other until you are swimming.
Floating up.
Yeah, when you are floating, so the forces are balanced. Even if you throw, suppose an object made of wood, an object made of rubber in water, so it floats up. Okay. So that when it is floating, the two forces, they are balanced. The gravitational forces and the upward force experienced by the object due to water, it is balanced.
Sir, even when we are sitting on a bench, we are getting pushed by our body is getting pressured by the bench. The bench is getting pressure of us, and the
Hmm.
bench is keeping pressure upwards.
Yes. Okay. So same way here also. So everywhere we can have forces to be balanced and forces are unbalanced, whether it be contact, whether it be non-contact. Okay. So like in the contact forces, we can see about the balanced forces like the tug of war we observed, where we observe two teams pulling a rope. So you have a rope here, and suppose there are two teams which are pulling the rope like this. Okay. If both the teams, they are pulling the rope with the same amount of force, you have the two teams, they are pulling the rope with the same amount of force. So the rope won't move anywhere. The rope is still there because the forces are balanced. Both the teams, they are applying the same amount of force. Then the forces are balanced. So this is an example of balanced forces in contact force. Okay. So even the contact and no. Okay. So there is doubt from Pranava. If I have if you place two magnets on two sides, if you place an iron piece in between in the air, does gravitational force can put down iron piece if we place very large magnets and the small iron piece? Okay, see. Basically, you want to levitate an iron piece with the help of magnet.
Yes, sir.
Yes, so you can do that. You can levitate an iron piece with the help of, but yes, if for that, if you want to levitate iron piece with a magnet, so see, now for that, uh, let's see. So you have to place your magnet here on top. You have to place your magnet here on top,
Yes, sir.
and you have to put your iron piece here. Now you have to, the distance between the magnet and the iron piece has to be so adjusted that the force of attraction by the magnet, okay, and the
Equal.
force, yes, and the gravitational forces. If both the forces are equal, so it will levitate in air. Okay. Yes, Shrestha, any doubt?
No, sir. So,
No.
but this comes under no, balanced non-contact force, right?
Yeah, these are balanced forces. See, you do not take it as the contact forces as balanced, unbalanced. You can, on the balanced and unbalanced, you can observe anywhere, whether it be a contact
Okay.
force or a non-contact force, right? We are defining contact forces on the basis of whether they actually require a physical contact or not. For example, if I ask a glass of water from you,
Sir, So this is a
if
non-contact force, right, sir?
yeah, this is a non-contact.
Unbalanced.
Yeah, unbalanced.
Okay, sir.
No, not unbalanced, it's balanced. The forces are balanced, it's levitating.
Okay, sir.
Okay. So Charan Tej has asked, sir, will weight measuring machine comes under balanced forces when an object is placed equally? Okay. So which machine are you talking of? The weight measuring machines, there are two weight measuring machines. You have a spring balance. Okay. So if you talk of the spring balance like this, yes, the spring balance will come under the balanced forces. If you hang some object over here, so due to the gravitational force, an extension is produced. Because of this, there is a downward gravitational force acting on this. And due to the extension, it is also being pulled up by the spring. So the two forces, they are balanced. Okay. And that's why it's hanging. Otherwise, it would have fallen down.
Yes, sir.
Okay. Any doubts?
Sir,
Sir,
Yes.
alleviating an object is interesting, no, sir?
Yeah, you can levy it. Just the thing is that the forces should be balanced. That's it.
sir, when
Okay.
we break a magnet, the small pieces also, the small tiny pieces also have north and south poles, right, sir?
Yes, even a single piece of magnet will have a north pole and south pole, however
Like,
small it may be. If it is
like,
a magnet, okay, so it has to have two poles. You cannot separate the two poles of the magnet.
okay, sir.
They are
Sir,
never
like,
separate.
So,
Yeah. Yes.
sir, like even the magnet gets breaks in the north pole side,
Yeah,
in the
whatever
north pole
direction.
side also.
Yes, whatever side you break, you will be getting your both the poles.
Okay, sir. Thank you, sir.
sir,
Sir,
before you gave the
Hmm.
swimming pool example right in the before slide.
Yes.
So
Yes.
in
Let's.
that, what is the upward force?
Okay. The upward force is called as up thrust.
Up, sorry.
Up thrust. Up thrust, or it has another name. We also call it as the buoyant force or the up thrust.
Okay, sir.
Okay, so these are the two force names for other forces experienced by an object when it is immersed in a fluid. Any
Okay,
other
sir.
doubt?
Sir,
Yes.
so when a magnet breaks, it will be given, you will have two magnets and each of them will have north and south poles. But when we
Yes.
try to join them again, we'll not be able to form a singular piece as it was before.
Yeah, because when you break the poles generally become like this. If you break this, suppose this was the north pole and south pole, you break it from here. So now it becomes something opposite. Now it becomes something like this. Now it becomes the North Pole and South Pole. This becomes the North Pole and South Pole. Something like this it happens. So they will never come close to each other. They will repel each other.
Okay, sir.
Okay. Any other doubts?
yes, sir, I posted in the
So
chat.
can you give an example of contact force, please?
Yeah, there an example of.
Contact force. So does the weight machine example come under contact force?
See, if you observe the contact forces, in the contact forces you have your force of friction. Force of friction is a contact force. You have your muscular force. If you want to use your muscular force to lift an object, to move an object, so you must have a physical contact with that object.
Okay, sir.
So you
Sir,
have to,
I
yes,
posted one in the chat, sir.
yeah, I see. You have given that how can the moving electrons produce magnetic force that can take iron nails grab to its side. So before that, it's a long law that you have to see the effects of moving electrons. Okay. First,
Yes,
we
sir.
study about the standing electrons and then we study about the moving electrons. The moving electrons, they create magnetic,
Sir,
The
yes,
moving electrons?
create magnetic field or magnetic effect. eventually if you observe, it has been observed that the whatever magnetism we observe today, that magnetism is actually arising because of electrons only. It's arising because of the movement of electrons only.
So can you
Yes,
repeat the word, the
how the
meaning?
how the magnetic force is produced from the just moving electrons, sir?
That's a great thing. Great thing means you need to go into the theory of relativity. Okay, like yes, with the theory of relativity, it was Albert Einstein who explained that how with the relativity you can explain the presence of the magnetic field. Okay, so
Then the
that's
upward
yeah,
force is called. Repeat the word again.
up thrust. It's here. You can
Up
note down.
crust. Okay, sir.
Up thrust.
Okay,
Thrust.
sir.
Okay, you have already studied about the thrust. Now this is up
Yes, sir.
thrust. So up thrust or buoyant force.
Okay, sir.
Any other doubts?
No, sir. No,
No.
sir. Thank you.
Okay. So anyone wants to ask anything? So today we
So
did
will
not
I
move for.
also have to write the exam on Sunday?
You can attempt. Try to see if you can answer them. Okay. Try to attempt the question. You will
Okay.
get a practice. You will get a practice of yes, how the questions are there, how to attempt them, how much time is there.
Sir, could
Okay.
you show the
So
last
it is
slide? Last
Yes.
slide.
so
Last
it's
The
like
slide.
last
Slide,
this
sir.
one,
Yes, sir. Yes. The last one.
the last one. Okay, this
Yes,
was
sir.
the
The
first,
present.
second, and this one.
Yes, yes, sir.
sir, is it like there's a different exam for each subject or all together?
Yeah. See. Today you have only physics. That means this week you have only test work from physics.
Okay, fine.
Okay.
So each week one subject.
Yeah. Sometimes both the subjects are combined, and sometimes you have just one subject. You are informed before that. You are informed around 3-4 days before.
Okay. So is it like an objective or subjective test this Sunday?
This week, 1 week you have objective, and next week you have subjective. It goes like
Okay, so this week it is objective or subjective?
yes. So objective, subjective, so on. It goes
Both.
both. So this week it is objective. In the next week it will be subjective.
Okay, sir.
Okay. Any
Sir,
other doubts? Or yes?
sir, I asked you about the broken magnet, right?
Yeah. So I told you we have.
So the you showed that only the left side one has changed its poles, but not the right side one.
Okay. See, either of them can change their pole. But once they break, these two poles they become similar. The two poles which are there, they become similar. And hence they never turn around. These two poles become similar. So either of them can change.
Okay, sir.
Okay, if see you are, if this is you are going, if you go into the depth, then you define the magnetic strength and everything. A lot of things are there. Okay,
Sir, could you once again explain about the spring magnet one, sir? That's what I didn't understood about it.
which one?
The spring magnet force one, sir.
Split magnet,
No, sir, the spring ones.
spring
Pranava
case.
asked. Yes, sir. I didn't
Okay, see,
understood about it.
okay, see, if you are hanging anything, so due to its weight, due to the gravitational force, the spring is being pulled downward. Okay, and due to the extension, when you are pulling the spring, so due to the extension, an elastic force is set up in the spring in the upward direction. So here this is the elastic force which is set up in the spring, and this is the gravitational force which is pulling this downward. Don't you? Okay,
Yes, sir.
bye.
Bye, sir.
Bye.